Well, hello students. Good morning, all of you. Due to some technical issues we are facing these days, the previous class was abruptly stopped or stopped abruptly. So, uh, in continuation of that previous class, we shall be studying this lecture. We shall be learning new things about the properties of electric field lines. Only two or three properties remain. So, let us first complete that, and then we'll jump to another topic. So, previously, we had about six or seven properties of electric field lines. Okay, six and seven properties of electric field lines. And let us now study for the next property. What is that? So let us write the heading properties of electric field lines. Okay. Okay, let me check if it is visible from that position or not. So, yes, it is clearly visible. So, the next property is that inside a conductor there is no electric field. Electric field is absent inside of a conductor. So, the question arises: what is a conductor? What is an insulator? And so many things. As of many of you know, the simple definition of a conductor and an insulator is that a conductor contains a large number of free electrons. Edge of some definitions you know. A conductor can conduct electricity, a conductor can conduct heat if we also take other terms into consideration. So, leave all those behind, just only think that a conductor has a large number of free electrons that can move inside something. Okay. So, the property is, let it write by a star, electric field, electric field inside a conductor is zero. Why? Why is that? Okay, we are now considering the reason of that. Because for this thing you have to learn the next topic. Well, we should be learning about the Gauss theorem. It says that the all the charges of a conductor come to the surface. Okay, all the charges of a conductor come to the surface. That's why electric field lines vanish inside it. And let us now develop that concept. Okay, so let it be a conductor, any conductor. Okay, any arbitrary size conductor, any random size, random shape conductor, let it be placed in an electric field. Electric field is like this. Okay. Try to make this straight, as straight as possible. Okay, not now, just understand these things. So you can see that if it is a conductor, electric line is piercing through it. Okay, but according to that property it is not possible. Why? It has a lot of free electrons. Okay, a conductor has a lot of free electrons. A lot of free electrons. The atoms inside of a conductor has a lot of free electrons. बहुत ही free electrons हैं. So if it is an atom, then it is an electron associated with it, and there are millions and trillions of electrons and atoms in there. So when electric field is given, so it is electric field, the direction of electric field is from this side to this side, and you know electrons flow against the direction of electric field. So electrons, all of the electrons here will arise here, will gather here, and to its counterpart, all of its negative charge if lie on this side, then all of the positive charge will lie on this side. This will occur. Now let me rub it. Why is it so? You will understand soon. So now, if there is a separation of charges, you can see that these are a source of positive charges and these are a source of negative charges. Then electric field lines start from this side to this side. So just analyze it. They let this electric field be EI, that is E inside. Analyze it. The external electric field is pointing to this side, that means from left side to right side, and the inside electric field is pointing to its opposite side. It will always happen like this. If the external electric field will be pointing to this side, then the internal electric field will be pointing to that side. So they will be opposite to each other, and this separation will continue up to when E is greater than EI. Okay, this separation will continue. Electrons will be gathered here and positive charges will be gathered to that side. But a moment will arrive. A moment will arrive when E external is equal to E internal. Okay, E external will become equal to E internal in magnitude but opposite in direction. At that case, this electric field will be cancelled by the electric field of this inside of a conductor. Okay, the inside of a conductor of electric field will cancel the external electric field, and that is the reason why at the inside of a conductor there is no electric field inside of a conductor. Now I think you have understood that. So now let us rub it, and we shall be jumping to a new property. So I assume that you have understood it, and if there is some other doubts or any question arising out of your mind, you can write it in the comments and I will try to clarify you, and I'll definitely come in contact with you through those comments. Okay, there shall be an email ID mentioned in the description. You can also just drop a mail in my at my uh, email box so that I can reach out to you. So you saw that the electric field inside a conductor is zero. These lectures are going to be long, okay? Because we are going in a very detailed manner. It is for you to understand these concepts, okay? If you understand these concepts very deeply, you are going to do good in exams or as well as some entrance exams, okay? Now let us come to the other property. What is that other property? So there are two electric field given. Okay, there are two electric field given. This is one electric field, and this is one electric field. Okay, this is E1 and this is E2. Both have electric field lines that are parallel to each other. These things are parallel to each other, and these things are also parallel to each other. So the question is that, can you identify which electric field is stronger? Can you identify which electric field is stronger? Okay, let us now drop into some observation. Let us use our observational skills, since we are humans and we have a lot of observational skills. So we can see that from this point of view, E1 has less electric field lines and E2 has a more number of electric field lines. Okay, more number of electric field lines in that area. If we consider this area and this area, both have same area, but the number of electric field lines in this field is more as compared to E1, which means, see, what is the closeness between it? And see the closeness between these lines. The closeness between these lines. So you can see that the closeness or the distance in this part is more as compared to this part, which means relatively we can say that the electric field lines of E1 are more distant than the electric field lines of E2. So what does this point say? What does this point say? This point says about the strength of electric field. The strength of electric field. So you can also come into that conclusion that E2 is generally stronger than E1. So we can write. So what we can write? Now let us rub this diagram. Let us just put these into a conclusion that the relative closeness between the field lines shows the measure of इलेक्ट्रिक फील्ड स्ट्रेंथ। अभी आपको ये समझना है कि जो जितना पास पास होगा उनके अंदर वो स्ट्रेंथ ज्यादा होगी। सो यू कैन सी दैट फ्रॉम नेचर ऑल्सो। सो आप अगर किसी के पास बहुत बहुत पास है तो आपका उनसे बॉन्डिंग अच्छा होगा, और आप अगर आप किसी से दूर चले जाते हैं तो आपका बॉन्डिंग खराब हो सकता है, स्ट्रेंथ घट सकती है। सो ये नेचर का ही रूल है, ये नेचर का ही रूल है दैट when these things are very close to each other, the strength is more. The strength is more, and when they are far apart, then it is a weak field. Then it is a weak field. So it is a very natural thing that you are facing these things in common days, like when after this class 10th exam you have parted ways with your friend, like many of you have parted ways, like someone is going to coaching a distant place, someone is just studying at home. So this distance, when you are at class 10 or 9 in the school, you were talking daily, you are just seeing each other daily. But when after this 10th class some of you might part ways, and after those things, when you finally meet after a year or two, things are not always the same as they was used to be. Similarly like this, so it is a natural thing. So the relative closeness between the field lines shows the measure of electric field strength. If it is if the relative closeness if the relative closeness is very small, is very small, then it is a strong field. This is not a point to be noted in here, just I am just showing you some notes of it. Now if it is large, what the relative closeness, then it is a weak field, then it is a weak field. So we just studied these things. You might have observed that I am drawing these things parallel to each other. Why am I drawing these things parallel to each other? Because these parallel lines so that the field is uniform, so that the field is uniform. Okay, so that these parallel lines show that the field is uniform. So now these are not the properties to be noting if someone is asking about the properties of an electric field. This is your property. We are just deriving some part of it, some notes from this line. Okay, so it is good. So as we have completed the properties of electric field lines, now let us, I would like to remove this and then start our new topic. So please wait for a minute. So let us now draw some electric field for some objects which have been, which can be asked in exams. Like, let us draw some electric field. If you are given a positive charge, a point charge, a positive point charge. Okay, roll, stop. Let me write the heading: electric field representation. Electric field representation. How are you going to represent your electric field if it has been asked? Okay, so so let us now draw an electric field representation. Means the drawing of an electric field. If it is a positive charge, it is a positive charge or a positive point charge. Positive charge, let it write be positive charge. So how will be its electric field? Okay, so this is a positive charge. Let us now consider that it is a point charge to for simplicity. So you just remember, I assume that you remember what is a point charge. A point charge is something, or what is a point object? A point object is something that we such that we can ignore its dimensions. Okay, and a charge on that point object, and you call it that charge to be a point charge. So what should be its electric field? Its electric field, as we know, is radially outward. It's radially outward. They extend out to infinity, just like starting from the positive point charge, they extend out to infinity. If it is an isolated positive point charge, they are radially outward. So just don't get confused. Again, if you are given a set of diagrams